Hey guys, long time no see. We're certainly missing you as teachers and hoping you guys are all doing well. Um, we've decided to make several videos uh, between the different classes to help you guys out with your different coursework. I was noticing that it seems like a lot of you have paused on the section about the ideal gas law. Um, it can look a bit complicated, but I think once you understand it a little bit more, it won't be as difficult. And so I'm going to go through and explain it a little bit to you guys now. All right, so the ideal gas law. Of course, we're talking in this section about gases. Okay, we're talking about how they behave, how we can understand some of their properties. The easiest thing I think to think about is if you were, to fill up a balloon, okay, full of gas, you would have the little gas molecules, or particles, whatever you want to call them, okay, throughout in here. Now, to make the ideal gas law make sense, all it's really talking about is what happens if you're changing different characteristics about how where the gas is. So, for example, so let's pretend that this balloon full of the gas molecules, where actually each of these gas molecules are now people. Okay? And, they're in this rubber balloon and they're trying to get out, right? So they're pushing, to get out. Okay? So there's this pressure that either the people pushing outwards or the gas molecules as they're bouncing off, okay, they're pushing outwards. Okay, now what if all of these particles were smushed down? Okay, so that all of these particles or all of these people ended up in a much smaller space. Okay, so if you can imagine, people in a big area being condensed now into a smaller area. Okay, there's more pressure now in there, right? They don't want to be close together. They're trying to push outwards. Okay, and so their pressure increases. Okay, now the ideal gas law is actually an equation like you would use in math. Let's see if I can do it just with this paint. PV equals N R T. Okay. What the equation says is that all of these things are related. The pressure is related to the volume, okay, is related to these different things, N and R and T. So N is the number of moles, okay, moles. Which, if you remember, maybe we can write this out. Let's get some letters in here. Moles. There's 6.02 times 10 to the exponent 23rd, so 6.02 times 10 to the 23rd molecules equals a mole, right? Let's lower the font just a little bit. Okay. So 6.02 times 10 to the 23rd molecules equals a mole. T is temperature, and R is a constant, which means it's a number that isn't going to be changing with everything else. Now, what do I mean that everything's related? Well, if you remember, because of in math, you could solve for any of these things. Okay, so if you wanted to figure out exactly what the V was, the volume, okay, you'd divide by P, or pressure. So you divide by this side, P divided by a P would equal 1, and then you would divide it on this side. So you'd have P V equals N R T. Okay. You divide by P this side. You divide by P on this side. Okay. And because P divided by P equals 1, you would then just be able to say V equals, or the volume equals, N R T divided by P. Okay. Now, you could do the same thing for any of these letters, and I'm trying to see, let's see. Let me just separate this out real quick so it's not confusing. It's real pretty, I know, but hey, don't have a mouse. I have a keypad right now. Okay, so V equals nRT divided by P. So you could also solve for N, you could solve for R, you could solve for T, you could solve for P, okay? It just depends on, if you needed to solve for T, or temperature, you'd have to divide this right side by N and R, and divide here by N and R. And so then everything would end up with T, and these would cancel out. And then you have the PV over nRT, or NR, excuse me. So one of the hardest things maybe to remember about the ideal gas law is that you have to have the right units. So temperature, you've heard of Celsius, you've heard of Fahrenheit, okay? And in this, for the equation, it needs to be in Kelvin, okay? So this is a scale that is used more in science, and you'll see it in your reading, okay? So it's a scale called Kelvin, where when it goes down to 0, it's absolute 0. Okay, it's a theoretical point where it's so cold that nothing moves. Okay, it's never been reached. Okay, but you'll read about it in this section. Okay, so let's see. I told you that N is moles. V, so volume, is in liters. P, so the pressure, is in atmospheres. And you can think, you're walking around, you don't really feel the weight of all the air and other gases on you, but there is an atmosphere of pressure on you. Okay, and so divers, for example, when they go down under the water, they are often feeling things like 2 atmospheres, of pressure, or twice as much as that normal pressure that you'd feel walking around. So that would be quite common. And so it's in an atmosphere. Okay, is the unit A T M. Is the abbreviation, or an atmosphere. So I'm going to bring in real quick. Let's see if I can get it in here. Okay, so this is what you're going to need. And this you'll see in your reading. In fact, I copied it from a spot in your reading. Okay, so pressure measured in atmosphere, volume measured in liters, N number of moles of gas, R the gas constant with the value, so constant number of 0.0821 liters times atmospheres, divided, so this whole top part divided by moles times Kelvin. And if you'll notice, these units, that seems kind of crazy, but you can see it's all related to the other units that are in this equation. So kind of challenge you actually to see what happens to these units when it's times by the other things in the equation. You'll see that very quickly these units are canceled out, or not really an issue. Okay, so and temperature, again, measured in kelvins, and you'll see in your reading how to convert Celsius into Kelvin. We can do a video about that later if somebody needs that as well. A little bit about what it means to be an ideal gas. Okay, this is called the ideal gas law. So we're saying that this is useful really under the most ideal conditions. We're saying certain requirements have to be met for the gas. Now that all generally doesn't actually happen, and so it's kind of approximation. Okay, so the ideal gas law is an approximation. And the main things that you have to think about are that one of the things that's supposed to be met is that the molecules are not associating with the other molecules, and hence why another one of the reasons I said, hey, think about people inside of this balloon is, hey, you've got a bunch of people in here. Often they could be associating, so-and-so's going out with so-and-so, or these two are friends, they're having lunch together, whatever, like they'll, the different people in here, or the molecules, would become associated more with each other. And that happens more and more as you leave gas form and become a liquid and then a solid. Okay, but here we're saying, okay, for our ideal gas, they're not associating at all. Okay, they're completely unassociated, and everybody in the room hates each other. Okay, so they all dated everybody else, and everybody broke up. It sucked. Okay, so the first thing then is that they are not associating, and then the second thing is that the volume of each of these molecules altogether, okay, bunched up, is basically nothing. It's negligible. Now, the volume that they make, okay, this V is different. It's, that's the volume that the space that that they're in, that they occupy. Okay, the balloon or the room. We're just talking when we say to be an ideal gas. Okay, these molecules, if you were to accumulate them or bunch them all up, their volume would be nada, nothing. Okay, so let's see. All right, guys. So I hope that helped. Hope none of you guys now are going crazy. Hopefully you can work through some of that now. Feel free to leave some questions with the video so I can answer them. Also, a lot of the things, conversions especially, that you might need. I talked about Kelvin to Celsius, or Celsius to Kelvin, or if you have to do any other conversions from one unit to another, a quick Google search also will bring up what exactly you need to do. But feel free to leave questions, and I'll answer them as quickly as I can. See you guys, and we miss you.